Welcome everyone, and it's about time that we begin. So the reason why I am not allowing you to unmute yourselves is because I'm going to put this onto YouTube, and for safeguarding reasons, I just can't do that. So I can't have your video and I can't have your voice as well. So that's the reason why I would just allow the form of communication via the chat. Okay, so you can all send me your questions, if any, through the chat, and I'll be able to see it. So for the first section of this lesson, we will be talking about the simultaneous linear equations. And basically, I suppose you all know how to solve the simultaneous equations, like the normal ones. But then today, I'm just going to talk about the cyclic simultaneous equations. So this might be something that you have seen many times already, and I suppose that most of you might know this method. So basically, it means that when the equations have unknowns that are arranged in cyclic permutation, which means, for example, A and B, B and C, C and A, that's the cyclic permutation. Or probably you can also have, for example, something like 2A adding B adding C, A adding 2B adding C, A adding C adding 2B. So basically they're in kind of like a rotation. When the coefficients are kind of like in a rotation, you can say that it's a cyclic simultaneous equation. And for these kinds of equations, the easiest way to solve it is always going to be combining all of them to find out the value that is represented by the same coefficients of all the unknowns, such that you can simplify it. Well, let's keep it there. You can simplify it to the sum of all the unknowns. And after you get the sum of all the unknowns, usually it's going to be pretty easy, because you can either just try to simplify it into a linear equation with one unknown. For example, like if you are subtracting each of these three equations from this one with the sum of the three unknowns, you will have one unknown remaining in each of them, right? And you will be able to find the value of it. Or in some other cases, you will be able to further manipulate this. You will be able to further manipulate this in order to solve different kinds of, oh, sorry. Yeah, that's right. A adding B adding to C, that's it. Yeah, just a miswriting there. All right. So that's it for these kinds of cyclic simultaneous equations. And sometimes they might look a little bit hideous. What I mean is that they can just try to camouflage themselves, and you won't be able to realize that it is a cyclic simultaneous equation. But, well, you just need to use your observation there to help you identify this fact. And essentially what you want is just the sum of all the unknowns, all right? And you can start from there to solve the questions. So let's take a look at some problems which are related to simultaneous equations. Let's say the first one, this is 2016 JMO B2. Well, question 12 is essentially just B2. It says that the points A, B, and C are the centers of three circles. Let's say this is A, this is B, this is C. So in JMO, you would also need to be able to sketch the diagrams according to the description. And it says that each circle is touching two other circles. So let's say I have that one, and that one. That's a little bit ugly, but hopefully you can understand what I'm trying to do here. Okay. So yeah, I have three circles now. Let's pretend that they're circles. And now it says that each circle touches the two other circles and each center line outside the two other circles. Each center lies outside the two other circles, which means I'm right, yeah? So the sides of the triangle ABC have lengths 13, 16, and 20. So let's say this is 13, this is 16, this is 20. What are the radii of the three circles? So basically, this is actually a cyclic simultaneous equation because you can see that the radius anywhere on the circumference is going to be the same, right? So let's say the radius of circle A are going to be A's, the radius of circle B are going to be B's, and the radius of circle C are going to be C's. Such that you will have three simultaneous equations now, where A and B adds up to 20, B and C adds up to 13, C and A adds up to 16. All right. So now it's easy for you to solve them. As I said, you just need to combine all of them such that all the unknowns have the same coefficient. So we have 2A adding 2B adding 2C equals to 49, such that A adding B adding C is equal to 24.5, right? So subtracting each of them, you will be able to find the radii of the three circles, which A is equal to 24.5 take away 13, that is 11.5. B is equal to 24.5 take away 16, that is 8.5. And finally, C would be equal to 4.5. All right. Yeah, so that's how we can solve this set of simultaneous equations. And then the radii of the three circles are just 4.5, 8.5, and 11.5 centimeters, respectively. Okay. Yes, Robert, you can just type your question in the chat if you need to, because I won't be allowed to let you speak in this lesson. Otherwise, I can't upload it onto YouTube. So please feel free to leave your question in the chat if there's anything that confuses you. All right, so that's one of the applications we have when we are combining the geometry questions and the equations. So as I said, usually it won't just exist as the equation itself. It would be hidden in some of these kinds of questions, like different scenarios, okay? So let's take a look at the next question, which I have adopted from the SMC, but then I thought it is pretty valuable and you will totally be able to solve it. So that's the reason why I'm putting it as the second example for this series. So actually, this question comes from one of my year 7 lessons. And you can see that if x, y, and z satisfies these two equations, now we have two simultaneous equations, right? And we want to find the mean of x, y, and z. So in order to find the mean of x, y, and z, I would do something different. Yeah, of course. Because A, B, and C are just some randomly given circles, right? And then the lengths, it didn't say which length is 13, 16, or 20. Yeah. So it just sets the three sides have lengths 13, 16, and 20. So it means that I do not have to know which is which and who is who. The question is just asking you, what are the radii of the three circles? So as long as I'm giving the three radii right, then I would not have to know which is which, okay? So that is totally fine if you have a different order, because these are just names, right? I just set them as A, B, and C. These are just names. And then for this one question, because it's looking for the mean of x, y, and z, it means that I'm looking for x adding y adding z divided by 3, right? And then we also know that for 3 unknowns and just 2 equations, I would not be able to find a definite solution out of these 2 equations, which means that in the end, I'm not trying to solve for x or y or z. I am trying to solve for x adding y adding z, and I can divide that by 3. So if you compare these coefficients, you can see that they have a difference of Chow Chow, why are you here? I thought you were studying for your exams. But yes, I know this is a question from our lesson, isn't it? And this is going to be okay, fair enough. So you can see that these two have a difference of 4x, these two have a difference of y, and these two have a difference of 3z. So what does it mean? It means that they are all one away from the coefficients, right? Such that if you are discovering the relationship between them, you just need to take away equation 2 times from equation 1, such that you get minus x, take away y, take away z, equals minus 30, which means x adding y adding z is 30. So this comes from equation 1, take away 2 times of equation 2. And after you know this, of course, the mean is just going to be 30 divided by 3, which is 10. All right? Yes, that's it. But this is for the SMC paper, so it might be different in the JMO ones, but I thought it would be good to know that sometimes if you can't solve for the answer individually, you can try to solve it as a whole. And this is also sort of like a form of cyclic equations, but it's just like the a little bit of an inverse of the cyclic equations. All right. So let's take a look at the next question. So this one is from the 2021 JMO B2, and this is pretty straightforward. 2 pizzas, 3 chilies, and 4 pastas. And that's 53 pounds in total. So let's say there's x, y, and z. So it means that 2x adding 3y adding 4z is 53. And then the second one, 5x adding 6y adding 7z is equal to 107. So how much more does a pizza cost than a pasta? So we are looking for x take away z. So now we can see that in this, oh, why am I writing ZZ? 7Z. They ate a lot. Yes, indeed, they ate a lot. So you can see that again, we have 3 unknowns and just 2 equations. And this time I want to look for x take away z. So just like the previous question, we just want to manipulate the equation somehow such that we will be able to find out what we want, right? So these 2 questions are extremely similar, which is the reason why I'm still including the SMC question in this preparation here. Yeah. So again, you can just try to observe the difference between them. You can see that each difference is going to be 3 as the coefficient. And coincidentally, well, 3 is 1 more than 2 and 3 is 1 less than z. So you can try to use the second equation, take away the first equation 2 times. And that's going to give us x take away z exactly. Right? Because I'm removing 4x, 6y, and 8z. So I still have 1x left, and I'm removing 1 extra z. And that's going to be removing 106, which is equal to 1. So the answer is 1. Okay? But of course, when you are writing it, try to write it more properly. I'm just trying to teach you like how we can think about these kinds of questions, but that's definitely not the proper way of writing it. If you want to write it as the proper way, first of all, you need to say, for example, you need to have the let sentence. So like let X be, like X pounds be the price of pizzas, so on. Y pounds be the chilies, and £4 be the pastas. Like Z pounds be the pastas. Okay. So something like that. And then you can list equations and solve it. All right. But then just try to write it more properly than I am in this lesson. Otherwise, you're going to lose some marks there, aren't you? Okay. So this for this simultaneous equations. And also sometimes we will also encounter some of these simultaneous equations with parameters. For example, this 2001 question B4. I believe many of you have seen this question before. So it says that a large rectangle has perimeter 300 centimeters, and it is divided up as shown into a number of identical rectangles. Each of them has a perimeter of 58 centimeters. And you can see that each side of these rectangles is a whole number of centimeters. All right. So first of all, you can see that the large rectangle has the perimeter of this width. Well, let's say that's going to be the length of the small rectangle. So let's say this is the length and this is the width. Now we can see that the length adding the width is going to be 58 centimeters divided by 2. Or you can just say 58 divided by 2, which is 29 centimeters, right? And for the large rectangle, so this is definitely a multiple of the width, right? Because it's a number of the small rectangles stacked up. So you can give it a parameter, say it's n. So we have NW. And that's equal to 300 centimeters divided by 2, which is 150 centimeters. Is that making sense? Yeah. And we want to find out the exact two possibilities for the number of smaller rectangles, and we can try to find the size of the large rectangle in each case. So it means that I need to solve for the n, right? I need to solve for the n in this case, which means that I can try to eliminate one of the unknowns we have, L, by, well, removing the first equation from the second one. So we have NW, take away W equals 121. And now we can just try to factorize it, because 121 is definitely a composite number, but it doesn't really have a lot of options, right? So we have n take away 1 times W equals 121. Okay. So now we know that n is going to be greater than 1, right? Which means that 121 can be broken down into 11 times 11, or 1 times 121. Yeah, that's a bad pun, actually. The tangerine. So it means that the width cannot be 121, first of all, because if the width is 121, it can't be adding up with the length to get 29. Yeah. So the width is either 1 or 11. When the width is 11, it means the length is 18. So n times the width is going to be 132, which means n is going to be 12. Yeah. So when width is 11, the length is 18, and n is going to be 12. When width is 1, the length is 28, and n is going to be 122. So these are the two sets of solutions. And the size of the large rectangle, well, you can just write it as 18 centimeters by 132 centimeters. And 28 centimeters by 122 centimeters. Okay. So that's essentially what we have for the simultaneous equation bits of it. Does anyone have any questions so far? Okay. So we can move on to the next bit of it, which is going to be like the indeterminate equation bit. So first of all, for the indeterminate equations, we need to understand what kinds of problems we are trying to solve here. So let me give you an example. Say, for example, let's say now I have some apples, each of them costing £1. All right. And then I have some bananas, each of them costing £2. Well, some expensive bananas, those are. So if I have 10 apples and, well, let's say 5 bananas, how can I change the value? Like, how can I change the number of apples and bananas without changing the total value of them? So now it's going to be £10 and £10, which is £20, right? So given that it's still £20, how do I change the number of the apples and the bananas? The drawings are getting to you. Nah, that's just my, well, you know, that's just my humor. You just have to take that, sorry. So basically, wow. You can see that each banana is worth 2 apples, right? Each banana is worth 2 apples. So you can swap 1 banana for 2 apples, or you can swap 2 apples for 1 banana. Does it make sense? So it means that, well, if I take away 2 from the apples, that's going to be 6 bananas, isn't it? And if I take away a further 2 from the apples, that's going to be 7 bananas. So 1 more. Yeah. So that would just be equivalent to taking the value of the bananas and subtracting it or adding it to the apples, taking the value of the apple, subtracting it or adding it to the bananas, and such that actually when you have one set of solutions for these kinds of equations, you can find all the other sets of solutions by swapping the unknowns, like swapping the quantities. Yeah. So these kinds of equations are what we call the indeterminate equations, because I don't have a definite solution of it, but I can find many sets of solutions. So the problem for these kinds of questions will become what we can do to find the first set of solutions. Because I know that if I find the first set of solutions, just like what we have here, 10 apples and 5 bananas, that's one set of the solutions, right? So if I know one set of the solutions, I will be able to move on using the values of each unknown and try to find out the other sets of solutions we can. Does it make sense? But actually, in this question, because the values of the apple and the banana are given, so actually the numbers in this question serves the function as the unknowns, but the apple and the banana serves the function as the coefficients. All right. So, well, that's just an idea to help you understand how it works. But when you're actually looking at these questions, you will see that we have 4 different kinds of analysis helping us to find the first set of solutions. So which analysis you use depend on the property of the equation. All right. So basically, the easiest way to find the first set of solution is by trial and error. Just try different values you can think of for one of the unknowns, and then until you find a valid solution for the other unknown. But that would be costing a lot of time, and that would be kind of a dumb method for smart kids. So that's the reason why we have different types of analysis according to the properties of the equations. So let's say the first one is the odd-even analysis. It can be used when one of them is odd, like the coefficients. When one of the coefficients is odd and the other is even. So we have 3 being the odd coefficient, 2 being the even coefficient. Now, 13 is also an odd number, and we know that even adding odd is odd, right? So now, 2 times something has to be even if I want integer solutions, which means that 3 times y is going to be odd, such that 13 is odd. So if I know that 3y has to be odd, it means that y is odd, because 3 is an odd number. An odd number multiplying an odd number will give an odd number, right? So it means that the y is odd, such that when I'm doing the trial and error, I just need to try for y equals 1, y equals 3, etc. So I only need to try the odd values, which means that I have taken away half of the invalid solutions in my analysis. Okay? So that's for one. And then if you are doing the last digit analysis, that is going to work for the cases which one of the coefficients is a multiple of 5 or 10. And then it works. So for example, 3x adding 5y is 19. Now we can see that we can't use the odd even analysis here. So spotting the 5, that might be something that I can use. So it means that whatever multiples of 5 must end with 0 or 5, right? So it means that 3x must end with 9 or 4, which comes from 19 take away like the units digit of 19, which is 9, take away 0 or take away 5. So it means that 3x must end with 9 or 4. Now, under that circumstances, you can just then divide anything that ends with a 9 or 4 by 3 to see what does x end with. So we can see that x must end with 3 when 3x ends with a 9, because 3 times 3 is 9, right? And it must end with an 8 when 3x ends with a 4, because 3 times 8 ends with a 4. All right, so that is the last digit analysis. So you just need to try where x equals 3, x equals 8, x equals 13, and so on. All right. So that's how to make it work. Make an acronym LORD for last digit, odd, even, remainder, and divisibility. That's a smart one. That's a really smart one. I think it would be nice to remember it as a mnemonic. But then the thing is that I put them in this order because like there's a preference level in them. So like it gets more and more complex when it moves down the list. That's the reason why I am putting it in this order. And then for the divisibility analysis, you can think about it as, well, a little bit alike the odd and even analysis. So it can be used when one of A or B, which means one of the coefficients, is a factor of the constant term. For example, 4x adding 3y is 15. 3 is a factor of 15, right? Which means that both 3y and 15 are divisible by 3. So now if I'm adding something to a multiple of 3 and I still get a multiple of 3, it means that that something I've added has to be a multiple of 3. Does it make sense? Well, if you're sleeping, it means that you're good enough. So I'm glad about it. So now we can say that if 4x is a multiple of 3, because 4 is not a multiple of 3, so x has to be a multiple of 3. All right. And finally, we have the remainder analysis, which means that, well, usually we won't want to take this type of analysis because this is kind of tedious. But then when we have got no choice and we don't want to do the listing method, which is like trial and error 1 by 1, I can use this method. All right. So, well, if this is boring you, of course, you can feel free to leave. Like no one's stopping you from there. The remainder analysis involves, for example, we can analyze the divisibility of 3. Now we can see a 3y there, which is divisible by 3, that has a remainder of 0. 37, which has a remainder of 1. It means that 7x also needs to have a remainder of 1, right? Now, if 7 divided by 3 has a remainder of 1, it means that x divided by 3 also needs to have a remainder of 1, because the remainder have the multiplicative property, which means that x is going to be equal to 1 or 4 or something like that. So you can start trying from x equals 1, 4, and so on. All right, so that's all the analysis that we're going to be talking about. Okay. So let's take a look at example questions. So the first one here can be a bit easy because this is from section A. So it says that a book cost £3.40 and a magazine cost £1.60. If Clara spends exactly £23, how many magazines does she buy? So first of all, we can simplify it. So let's say a book is B, a magazine is M. So we have 340B adding 160M equals 2,300. And then we can divide all of them by 20. I can divide all of them by 20, such that I have 17B adding 8M equals 115. Right? So what we can do here is a bit of the odd-even analysis, because we know that this is even and this is odd. So it means that B has to be odd as well, right? So first of all, we can try B equals 1. When B is equal to 1, it means that 8M is 98, which is not divisible by 8. So we can just try to eliminate this option. When B is 3, it means that 7 in B is 51, and then I have 64 for 8M. So M is 8. So that's a group of solutions we have. And then when B is 5, it means that it's going to be 85. And then 8M is 30, which doesn't work either because 30 is not divisible by 8. And when B is 7, and 17B is going to be 119, which is greater than 115. So this won't work either. All right, so it means that that's the only set of solutions, which means there are 8 magazines. So that's a simple application of it. And then there are also some sort of combination between the Fibonacci sequence or anything like that with the indeterminate equations. So in 2021, we had this one question, and I think it also showed up in the 2008 paper. So it has actually came up twice in all these past papers. So it might be just trying to get to these kinds of questions that you need to try to use the letters to represent the values first, and then try to solve the indeterminate equations. So this is one of the logics of the question. So it says that in this one, every term after the second is equal to the sum of the previous 2 terms. So definitely this is a Fibonacci-like sequence. And all the terms are positive, and the 8th term is 400. So what is the minimum value of the 3rd term? Now, first of all, I can just try to list all of them. So you're naming the 3rd and the 4th term. I think that's okay. That's okay if you start from the 3rd and the 4th. I'm not sure if it is going to affect the outcome. I'm not really sure about that. But me personally, I would start from the first 2 terms, given the question. All right, you don't have to spam me like that. So we are just going to list out all the terms. A adding B, A adding 2B, 2A adding 3B, and then 3A adding 5B, 5A adding 8B. How many terms do we have now? 6. All right. So then we have 8A adding 13B and 13A adding 21B. All right. So that's going to be ending up with 13A adding 21B is 400. Yeah, so that's a little bit hard to solve this one. We can use a little bit of divisibility analysis there, because 400 divided by 3 has a remainder of 1, and 21b divided by 3 does not have a remainder because 21 is divisible by 3, right? So 13a divided by 3 has a remainder of 1 as well, which means that a is going to be within the range of 1, 4, 7, and so on. Yeah. Is that the 9th? 1, 2, 3, 4, 5, 6, 7. Oh, right. That's the 9th already. Ha, can't even count. Oh, if that's the case, it makes life much easier. 8a adding 13b is 400, which means that 13b has to be divisible by 8. Now it means that b is a multiple of 8. And b has to be smaller than 400 divided by 13, which is going to be 30. So that is going to be less than 31. And it means that b is going to be less than that. So it means that it's 1 hour. It's 1 hour. But we are almost there. I just have 2 questions left. So it means that b can take the values 8, 16, or 24. Right? It can't take 0 because every term is positive. So when b is 8, 13 times 8 is going to be 104, which means 8a is 296. So a is going to be 37. So a adding b is 45. And then the second one, when b is 16, it means 13b is going to be 208. So 8a is 192. A is going to be 24. So a adding b is 40. And then when b is 24, it means that it's going to be 312. 13 times 24, 312. Yes. So it means that 8a is going to be 88, which means a is 11. So a adding b is 35. So the minimum value of the third term is 35. Okay. And then we will also take a look at the 2022 question we had. So maybe some of you did it last year. So this is one of the questions we have from 2022. And it is a very comprehensive question. So it involves geometry, it involves the place value, which is like the number theory, and it also involves the algebra. So basically, first of all, we can try to write them as, well, this is like 10a if a is a digit. So it's 10a adding b, 10a adding c, 10c adding d. So probably I'm just going to write it here. 10A adding B, 10A adding C, 10C adding D, and 10B adding D, right? Well, it's okay. So basically all of these added up is going to be 360 degrees, which is the interior angle sum of the quadrilateral, right? So we have got 4 unknowns here. How do I try to make it a bit simpler? So first of all, we can see that combined all of them, you're going to get 20A adding 11B, adding 11C, adding 2D equals 360, yeah? So you can just try to combine this into 2 large unknowns. The first one being 2 times 10A adding D. The second one being 11 times B adding C. And that's 360. Right? So now we can try to analyze this equation. Yeah, it's okay. Don't worry. If you want to listen, you can listen. If you don't want to listen, you can just do whatever you want. Like there's no compulsory parts of these kinds of lessons. So it's just about how much you want to hear from me. All right. So no worries at all. Okay. So in this one, we can see that A and B and C and D, they are all digits, right? So it means that the maximum that 10A adding D can get is going to be 99, which means that the maximum of 2 times 10A adding D is going to be less than or equal to 198, right? Which means that for 11 times B adding C, that's going to be having a range of, well, that's going to be smaller than or equal to B adding C has to be 2 at least. So it's going to be greater than or equal to 22 and less than or equal to, what's that? 200, so 162, right? Okay, so we can try the maximum of B adding C. B adding C has a maximum of 18, right? That's going to be, sorry. It's going to be greater than 162. So B adding C, why is it 10A? It's okay. Because we have 20A there, right? So it's 2 times 10A. It's 2 times 10A and 2 times D. I'm just extracting the common factor from 20A and 2D there. The reason why it's 28 is because AB is written as a 2-digit number, which the A has a place value of 10, right? Because it's in the tens place. So we can write it as 10A. And then I have 2 of it, right? Okay. So now, because we know that 2 times of 10A adding D has to be smaller than or equal to 198, it means that 11 times of B adding C has to be greater than or equal to 162. And when B adding C is 15 or 16 or 17, yeah, the maximum is 18, right? So we can see if it's going to work there. I'm just breaking it up by the place values. Because CD is a 2-digit number where C is in the tens place. So for example, it's 12. So if 1 is in the tens place, it represents 10 times of 1, right? So first of all, when B adding C equals to 18, it means that, I can do a little bit of analysis there first, because this is even. 2 times of 10A adding D is even. So it means that 11 times B adding C has to be even as well, such that 360 is also even. So it means that B adding C can only either be 18 or B adding C can be 16. 15 and 17 are naturally eliminated. Because 10A adding D, A and D are both digits. A and D are both digits. So the maximum of A is 9 and the maximum of D is also 9. So the maximum of 10A adding D is 99. And 2 times 99 is 198. So it's going to be equal to or less than that. So now, knowing that B and C are either 18 or 16, we can just try to form the solutions. If B and C is equal to, if B adding C is equal to 18, it means that B is 9 and C is 9. And also 11 times 18 is 198, which means 2 times of 10A adding D is 162. Which means 10A adding D is 81. Now D is going to be 1 and A is going to be 8. So we have the solution. The 4 angles are AB, AC, CD, and BD. So 89, 89, 91, 91. So these are the 4 angles. And then when B adding C is 16, it means that there are going to be different possibilities, which are either 8 and 8 or 7 and 9, right? So these are the 2 possibilities for the 2 angles. Now, if they add up to 16, it means that it's 176 for 11 times 16. And then what we have remaining is going to be 184. So 2 times 10A adding D is 184, which means 10A adding D is going to be a 92. So A is 9 and D is 2. So then we can have 2 more sets of solutions, which are going to be 98, 98, 82, 82. Or we can have 97, 99, 72, 92. All right, so these are the 3 sets of solutions we have. As I said, this question is pretty comprehensive because, like, first of all, we need the knowledge of geometry to know that it's 360 degrees. And then we need the knowledge of place values to be able to break down each angle into the places so as to control our unknowns. And finally, well, factorizing it to group into 2 groups and do a little bit of analysis in indeterminate equations and try to use the, like the boundaries, like the range that we can take to find the answers, okay? So that's everything for today's lesson that I'm going to talk about, which I expect some of you might have a little bit of questions regarding the stuff that I've just been talking about. So you can let me know if there's any questions. Well, if not, then of course you can leave the classroom whenever you want. Okay, thank you, everyone. Thank you, thank you. Bye-bye. Yeah, it's okay. If you still have got any questions, please feel free to stay a little bit longer and let me know about it, okay? So I'm just going to stop the recording now, such that